sorry, first of all, I want to let you know we have a course website, and the website is at here. Okay, this is the URL, and you can find the slides we are going to use today here, PPTX. So if you like, you can download it right now, so that you can read those slides on your laptop. Extension. Okay, got it. Okay, where to find the URL? Okay, this is my personal website, so you can find this from the faculty page of our department, or just Google my name and CGU AI. Then you should be able to go to this. It is a GitHub page. So it will look like, and go to the courses and Computer Vision 2024, and this is our course website. Alright, so let's okay, let's go. Okay, so what we first of all, I want to introduce myself. Okay, I'm currently an assistant professor at CGU, of course, and this is my short history. I grew up in Taiwan and got my master and PhD degrees at the National Taiwan University. Then I went to US, the UC Merced, University of California at Merced. That is a new campus, and I spent 6 years there and was a short-term intern at Google and Siemens. And then I come back to Taiwan, be a postdoctor at the National Taiwan University. This is the IOC Center. Okay, so I spent 3.5 years there, and my interest was. Okay, I should say I have another research interest, that is stock investing. Okay, so I spent 4.5 years figure out some complex questions there, and I finally figured it out. Yes, okay, but it is unrelated to our computer vision course, so I will spend too much time on that. Okay, so currently now, first of all, this is the scope of computer vision. Okay, so there are many problems and tasks, and therefore there are many data sets. So some of them are very famous: ImageNet, CIFAR 10, CIFAR 100, and MIST, Celeb 8, NTU RGB. This NTU is not the National Taiwan University. This is another university in Singapore. It is a national technical university. Okay, so okay, fine. So that this NTU RGB plus D means RGB means the color space, the usual video and image. The D means depth. This is a human action data set. They use depth camera and the video together to capture videos of human actions, and we want to, the task of this data is to recognize actions from video and depth image plus video. So to solve those problems, there are many algorithms. So these shown on the slides are the famous one, and there are more and more algorithms released or published every year. Okay, and however, if you want to develop the programs to implement those algorithms by yourself, it's very tired. So there are many existing tools to somebody else implement those algorithms, and you can just use that. Okay. So for example, the most useful and famous for us is the OpenCV, Open Computer Vision Library. Okay, and I will show a few slides later. Okay, then there are some programming languages to you can use to implement those algorithms. The most popular one should be Python. But if you want to a high-speed, high-efficient implementation, C and C++ may be a better choice. And MATLAB, it is. How many of you know MATLAB? Okay, less than half. Okay, so I need to slightly introduce it. MATLAB is a commercial software program, and it is very expensive. But however, I should say, you can use it for free on our campus because we purchased a few licenses here. So all students at our campus can share the license. And it is very, very convenient. You can just use a few statements that you can create a very, very elegant figures, etc. Okay. So basically, why it is called MATLAB? Because in the beginning, it was designed for matrix computation. So it's called MATLAB. Okay. So my first industry job was at this company, PixArt. It is an IC design house, and its product is the CMOS image sensor. So when I joined the company in 1999, or less than century, okay, it was just a startup, and it's most okay. So what can a CMOS image do? It can be used to sense the movement of a mouse. So this is the optical mouse, and currently most of the mouse are optical mouse. But 20 years ago, there is a mechanical mouse. There is a ball inside the mouse, so that when you move the mouse, you roll the ball, and it can sense how much you moved. And okay, so which one is more convenient? Of course, the optical one, because if you have the experience, when you use the optical, let's say mechanical mouse for a few months, you need to clean the ball. Okay, and the most famous product of this company is the this some of them know. Do you know what is this? Wiimote, right? And there is a sensor, optical sensor, in the Wiimote. Here, this is at this region, okay, and that was designed and by this company. So that is when we is on its peak, the company makes tons of money, and I quit too early. So you can see, if you remember, the Wii is released around 2006 or 2008. So this is a stock price of this company. It I purchased it around $13, and it goes to $900. Okay, so because this is a monthly average, so you will not see 900. The average is around maybe 500 or 600. Okay, never mind. Okay, nobody can predict the future. So fine. However, some application of the CMOS image sensor is the optical finger navigator. On some high-end cars, you can find it on the So it means if you adjust for example, the music volume or go the forward, backward of your music, you don't need to touch the panel. You just use your finger, move it up and down, left and or right. Though you can do what you want. Okay, there is a CMOS image sensor under the thumb, and of course this is webcam. So why? Okay, there are a lot of webcam on your cell phone, I should not say webcam, a camera, in your laptop, and anywhere. So why a CMOS image sensor is a good choice for webcam design? Because cost. Okay, for a webcam, there are two chips. One is the CMOS image sensor. It is necessary because you need to get the image data. So there must be a sensor. Okay. However, the second chip is the image processing chip or control chip. Okay. So the company PixArt, it integrates the two chips into a single one and significantly reduce the cost. So it can there is an advantage for this company to sell such kind of chip. Okay, so currently this is a Switch, Nintendo Switch Joy-Con, and there is still a camera, a CMOS image sensor inside this part. Okay, it is also made by this company PixArt, and there's another statistic. Mouse around the world, 80% chip is 80% of the mouse in the world use this company sensor. Yeah. Okay. But however, because optical mouse is a very mature product, so there are some small competitor. They compete this company with price. So although this company is the, I should say, biggest CMOS mouse, optical mouse chip seller in the world, it doesn't make as much money as it sells the remote sensor. Okay, so you can see its stock price is not very high right now, but not very low. Okay, so when I was a research assistant at the academia, at the NTU, I was a master student there. My study topic is color, in particular multi-spectrum color. So what is multi-spectrum color? Okay, usually we will say to describe a color, we have three attributes: red, blue, and green. Okay, but however, if we have multi-spectrum, means here if we describe a color use a lot of attributes, then what is the benefit? Okay, the benefit is if you want to reproduce sun treasures or the ancient paints, then it will be more accurate, because under different illumination, your reproduced product will be more realistic. Okay, my second industry company is Eltec. So it is a integration of an IC design house and a manufacturer. So its main product are digital cameras, including, for example, because it has an IC design, it has a IC design department. So, for example, this is the HTC M1 and HTC One N8. It is the first cell phone in the world which can generate depth image, and the chip is designed by Eltec. Okay. And however, you can see the peak of the company is around 2009 to 2010. Then it goes down, 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 down. Do you know the reason why its product is less favored by consumers? Okay, the reason is iPhone. iPhone was released in 2009, if my memory serves correctly. And in addition to iPhone, there are a lot of smartphones, and the cameras on those smartphones become better and better. Then less people want to buy the consumer level digital cameras. So it sales and revenues and profit goes down, 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 down. All right. Okay. Okay. So when I was a research assistant at Academia Sinica, my research topic was alpha mating. So okay. So this is a academia problem. So let's see. There are a lot of problems and tasks on the second slide, right? And this is one of them. We are going to solve a problem. Yes, given an image. So the first column is the input image. There are three different parts. One is the transparent part. For example, in this image, it is the black region. It means you can when you have something translucent, okay, you can see the background. So the black one is the background, and the white one is the foreground. It means it is total opaque. You cannot see the background. And between the background and the foreground, there are some regions translucent. Okay, so the problem is to given an image, given this tri-map, you are going to determine or predict which is the level of transparent. Okay, so for example, you see, okay, this donkey for this hair region. Okay, we need to predict how much pixel by pixel is its transparency. Okay, if we can accurately calculate that, then we can easily change the background. Okay, so that is the purpose of this task. Okay, and for this, the fourth column and the fifth column, they use different. The object is the same, but the background are different. Okay, so that's what we want to do. Okay. Alright, then I went to UC Merced, and where is this California, and this is Merced. And I also went to Los Angeles Google and the Siemens Research at New Jersey. Okay, then during the 6 years of my PhD program, my research topic focused on single image super resolution. So what is a super resolution? It means given an image with a small resolution, we want to generate another image. Okay, the content is the same, but I need to fill in a lot of details to create a high resolution image. Okay, so there are many algorithms and methods try to address this question. And I published a paper in the ACCV conference. ACCV means Asia Conference on Computer Vision. Okay, this is a local, I should say local. It's an international conference, but the level is not as high as the top conference. The best conference in computer vision is CVPR, computer vision and pattern recognition. Okay, the second is ECCV and ICCV, and then is ACCV, right? Okay, so how to measure the impact of this conference? There is an index called H5 index. H5 means if the paper, after the paper was published, within 5 years, how many other papers cited it? So the more citation, the better, the higher impact. Okay, but why only calculate 5 years? Because citation usually degrade year by year, so they just pick a 5 as they say this is a proper number. Okay, so they calculate the inference within the 5 years. Also, they can calculate because within a conference there are hundreds to thousands papers published in the conference. They calculate the average of those papers and they get H5 index. So the higher, the better. The best one is CVPR. It is an annual conference, and it is an American conference. So the city hosts the conference always in the US. Okay, so this the idea of this paper is, okay, given an input image I0, I can slightly shrink it. So I will get a I-1 and I-2. Then I search for similar patches at the same location. For example, this is P2, it is corresponding to this R2. And then if I find some similar patch, if P1 is similar to P2, then I will copy the region to another one. So this is a method to create a high resolution from a single input. So this is why it's called a single input, single image super resolution. Okay, in CPR 2013, I published another paper. This is also a single image super resolution problem, but for face images only. Okay. So my idea is, okay, because most faces share the same structure. We have some facial components, eyes, nose, mouth, etc. Okay. So what I want to do is, given a data set, these are candidates in our data set, I first localize those facial components, where is the eyebrow, eyes, mouth, and nose. And I go through the data set, find the most similar one component, and borrow their component and pass to the target human faces. So that's all. Okay, so this is also a way to generate a high resolution, use other people's facial components to do it. So this is the, so now maybe you can sense what computer vision is trying to do. We want to either understand the image. So because I need to understand where the locations of those facial components are. So I use some existing algorithms to localize facial components. Okay. Then once I understand the image, I use it for my purpose. So this is the image. What is the computer vision want to do? Okay. So in the same year, in ICCV 2013, I published another paper. Okay, the paper is also single image super resolution. So the innovation of this paper is, I should say, before this paper, all existing paper try to generate a high resolution image through this way. Given a small patch, they will find a single but a complicated function to generate a high resolution patch, and then pass it patch by patch. They can generate a high resolution image. Okay, so my idea was, it looks very expensive because the function is very complicated. So what I want to do is, given a patch, can I split the space of the patch into many tiny subspaces? And in each tiny subspaces, I create a mapping function, so that given a small patch, first of all, I need to find which subspaces the small patch belongs to. Once I found it, I use a very simple linear function to create its high resolution patch. Then I can create or generate the high resolution image. So what's the benefit? The benefit is the computational cost. So those are the existing number, and the PSNR and SISN are two metrics to measure how similar the generated high resolution patch is from its ground truth one. Okay, so for PSNR, SSIN, the higher the number, the better the similarity. Okay, so as you can see, the state-of-the-art method in that year was Glessner's method, and its PSNR and SSIN is very similar with ours. But however, Glessner's method needs 10 minutes to generate a high resolution image, but our method only needs 14 seconds. So that is the improvement. So those reviewers, of course, they say, oh, you can generate a similar result, but you use much less cost. So of course, this is an improvement. They accepted the paper. When I was an intern at Siemens, okay, my research topic is, okay, so you can see this is a digital X-ray machine, and when they took the X-ray image, there is a anti-scatter grid. Okay, it is usually it is square, and Siemens is the biggest, I should say, medical device manufacturer around the world. Okay, then they are trying to develop some new devices. Okay, they have ideas. Can they change the shape of the anti-scatter grid? Is it necessary a square? Can it be the shape of a hexagon? So the hexagon, a lot of hexagon will look like a honeycomb. Okay, so but the problem is, if they use the shape of a hexagon, then there will be more shadow on the, because those lead will generate shadows on the X-ray image. So my task at during the intern was to reduce those shadows on the X-ray images. I spent 6 months there, so it's an interesting experience. See, to imagine what the device in the future will be. Okay, then in the next year, I published another paper at ECCV, and okay, in this paper, what I want to, the problem I address is, see here. Okay, we use the two metrics, PSNR and SSIN. They are widely used in 2013. But my question is, are they fair? Is it reasonable to use them? Do we have any other better metrics? Can we try it? So the metric, does the metrics mean? The metrics means you use some algorithm or method to measure whether the generated image is very similar to the ground truth image. Okay, but however, human perceptions may be very different from those algorithms. So how to solve the problem? First of all, we need to collect the score of a human perception. So you can see, so let me explain the dot here. So there are many different metrics. So this is PSNR and this is SIN, the most widely used two metrics. And we try different metrics. For example, VIF, NSSSIN, and WPSNR, and UIQI. So there are many existing metrics. We just use that to measure whether it makes sense. And what's the point here is, the point, every point in this figure is means, given a pair of test images, we ask human subjects, or the human subjects are my classmates, my or I said someone I know. I just asked them, could you help me and look at some images and give us your scores. Okay, if you feel the two images highly similar, you please give me a score of 10. If you feel they are very, very unlike, then give me a score of 0. Okay, so we measure it, and so that at every point, the y-axis means if we use the matrix, for example PSNR, to measure that, so what is the result, and the axis means the human subjective score for the similarity between the two images. So for the best case, it will be a straight diagonal lines. But however, we after the collected data, so you see some of PSN. This is the result of PSNR and SIN, and some of them is much better than it. For example, the UIQI, it is those points scattered around the diagonal. So it's much. It is so we want to provide some evidence so that other researchers think, okay, maybe there is a better way to measure the similarities between two two images. And for the right hand side, okay, so this means when we say we are going to generate a high resolution images from low resolution, but the question is, when you have a high resolution, how do you generate the low resolution image? Okay, usually there are two steps. First is blurring. Use a Gaussian filter or somewhere apply on the high resolution image, and then you do subsampling. Okay, but however, for a Gaussian filter, there is a parameter called the sigma. It means the standard deviation of the distribution. So how much should be the value? Nobody asked the question before, so we try different combinations. So here, okay, we try when, and there are another factor is the scaling factor. So for high resolution image, when you generate a low resolution image, how many pixels you got a sample? So that is scaling factor. So we try different combinations of the scaling factor and the standard deviation. Okay, and we draw this figure. It means for each line, it means we apply different existing single image super resolution method to reconstruct the high resolution one, and how well they are based on their scaling factor and standard deviation. So we draw this. So you can see there are many different combinations. So what we want to do here is we want to show for different scaling factor and standard deviation, different method will have different results. So when you see the title of this paper, you can see this is a benchmark. So benchmark means we try different methods and we want to provide a surveyed result. Okay. So in this paper, we didn't provide any new algorithm. We just systematically check those state-of-the-art algorithms. Okay, then this is a journal paper. Okay, here. We published the paper in CPR, and 4 years later, my advisor, okay, I don't know why I should say, he has the idea. Okay, the idea is, okay, for this method, phase hallucination, what will happen if your input image is compressed image? Because there are noise in compressed image. For different compression algorithms, there will be different type of noise. And what is the most, I should say, popular compression method that you used? JPEG. Are you familiar with JPEG? Okay. At least when you browse the internet, you see a lot of images. Some of them, or most of them, are compressed by JPEG. So when you download a file and when you see the extension is .jpg or .jpeg, then it usually means the image is compressed in JPEG. Okay. So the question is, when the input image is compressed by the JPEG algorithm, then will the phase hallucination work, and how well it will work? Okay, so this is Obama's image, right? And this is the last column is the original image, and there are 4 rows. Which means we use, so I should say, for JPEG compression, there is a factor called compression ratio. So if you set the compression ratio as 99, then it means you will have a relatively large image. The compression rate will not be very high. But if you set a very low compression rate, you set a very high compression rate, it means the quality will downgrade quickly. Then you will have a very noisy image. For example, this one. When you see the first row, in this row we set the compression rate as 90. So this is the Obama face, and in this row we set the compression rate as quality factor as 25. So you see the face is not as clear as this one. Okay, because however the file size is relatively smaller. Okay, so we invested the problem. We used the algorithm and tried on different level of compressed image, and we see the results. So the algorithm is the same, but the test dataset is different. So you can see this is following work. We just extend the research field, and so when we finish it, we publish it in IJCV. So IJCV is a journal. Okay, the same. There, as I mentioned, how do we measure the quality of a conference? Use H5 index, right? The same. H5 index can be also used to measure the quality of journal. So for computer vision, the best journal is TPAMI, and the second top journal is IJCV, based on the H5 index. And then this is another paper published in 2017. Okay, so when you see there are a lot of dots. So what is this? It is almost the same like this one. Okay, so let me explain this. When I published the paper in ECCV, I have a second author because he was a visiting student from China, and okay, he helped me do something. Okay, because we are in the same lab, so we will try to help each other. So he became the second author of this paper, and then when he went back to China, his advisor is interested in the topic, and in China, they can easily find a lot of human subjects to participate in the work. So I'm not sure whether he hired or he find another undergraduate student, etc. However, so you can see they collect a dataset much larger than ours, and they also consider another question. In this paper, we use two images to compare. One is the ground truth image, another is a generated image. But can they learn a way to measure the quality of the generated image without the ground truth image? Yes, they can. Of course, you can develop any algorithm to do it. But however, how do you measure the algorithm works or effective? Use what? Human subjective scores. Because so this way they can develop many different algorithms. But if those points are very close to the diagonal line, then it means the algorithm, even without the ground truth image, is effective because it matches the human subjective perception. Okay, so that's the paper they published in CVIU. Okay, and then when I was a postdoc, I try to help. There are some master students in my boss lab, so they have some questions, and I try to help them to address their own question, because I was a reviewer of those top conferences. So I should say I try to help them to convince those conference reviewers whether this work is solid and reasonable. Okay. So this is a paper I helped a student published in ACCV again. Okay, there is an existing method called star GAN or star GAN. Star GAN. Okay, some people maybe in Europe they pronounce it GAN, but we here or in the US, I don't know, I'm not sure. So Marcus, how do you pronounce this one? GAN. Okay, fine. Okay, and and Jay, how do you pronounce the GAN? Okay. Okay, fine. All right. If I pronounce it GAN, okay. I hope you can understand what I'm talking about. All right. So his idea is he tried to add a new component to make the algorithm can be semi-supervised. Also, this is his new head in the new network architecture. So that's all. And let's see our result. So this is the original result. It means if you only have 0.3% percentage training images, then your network can be very effective. But however, if we use the semi-star GAN, okay, and we have the same limited size of training images, our results are much better. Why? Because this is a semi-supervised approach. Semi-supervised means you don't need to label all images. You only need to label a few portion of the images and use those labeled images to label those unlabeled images. This means semi-supervised. Okay. Because of therefore, this is a way to reduce the cost of labeling images. So this paper was published in ACCV here, and then I helped another student publish a paper in FG. FG means facial and gesture. Okay, it is a relatively small conference. And it focuses on understanding human images related to human beings. And the idea, okay, so let me explain what is a facial action unit. Most of us, I should say, there are many facial expressions, and usually we categorize into neutral, smile, angry, disgust, sad, etc. Usually there are 7 or 6 different facial expressions, labels. And facial actions means because there are many muscles on our face, and when the muscle constraint, you will have a certain appearance change on your face. Okay, so those muscles called those group of muscles for facial action. Okay. So when you want to use the muscle of my forehead, then you will see some wrinkles there. Okay. So you can see there are AU6. Okay, it means the brow roller here, and the AU6 here. For different images, they hire those experts to label those facial action units. So it's very expensive. But however, the student he has an idea. The idea is for some people, even because of their appearance, for this guy, he is not sad or he is not digest, but because the shape of his mouth, he looks like there is a AU15, but in fact there is not. Okay, so this is called the identity property for different people. Some people have, and some people doesn't have it. So he tries to develop a network so that it can utilize the identity information to improve the facial action unit detection. Okay, and my postdoc research topic is the robot. We want to use the robot to help the senior citizens at home if they live at home alone without their children, etc. So you still can see the robot in my office, and but however there are two different projects. When the project was finished, we published a paper in MobileKai. So this is a human-computer interaction conference rather than computer vision. Okay. Why? Because we didn't develop any new algorithm or create some novel application. We just use existing method to create a new application. So we didn't publish it in any computer vision conference. Nobody or the reviewers in those computer vision conferences won't care about your application. They want to know any new novel result, a novel idea, or significant improvement. Okay. But however, the MobileKai, it is a conference focused on how we use machines, how the machines can help us. So they are interested in this topic. Okay. So here, so you can see I used because there is a camera on the robot. So we use the robot to go around in a house and to capture images of the senior. Okay, and the robot once it is full charge, it can work 7 to 8 hours. So during the 7 to 8 hours, we will collect a lot of tens of thousands of images. So my problem is, how do we pick 6 most useful or informative photos from 10,000 images? So this is a video summarization problem. Okay, how to pick? And we try some existing method. It doesn't work because no existing method address the videos for so long 6 hours, and most of them are very boring. Because see, if there is a senior sitting on a sofa and watch the television for 3 hours, the images are all the same. Okay. So how do we? So we need to develop our own algorithm. It means here you can see for this case, the robot capture the images for a very dense period. Then the lady went out, and because she was absent, there is no any images with a human. But she came back, and she went out again, and she came back. So there are a few clusters. This is the first cluster, this is second, and this is the third, fourth, and fifth. So our approach is very simple. First of all, we cluster those images. Then we pick up the most representative one from a cluster. So the idea behind the algorithm is very straightforward and simple. But however, it works for us, right? And okay, this is another paper. I try to help a student. The student want to improve some existing generative algorithm. It means, given the input Chinese characters, and this is the calligraphy character, she wants to generate as good as the calligrapher's characters. Okay, And okay, there are some existing methods addressing the problem. And her idea, I should say, my idea. Okay, because when when we I got the idea and she implemented it. So okay, at least she is the first author. Okay, all right. Let's take a break for 10 minutes. Right. Okay. So our idea, very political. Our idea is to use the structure of Chinese characters. So what does it mean? This is Chinese character, and it is structured. For every stroke, there are an existing coding system. For example, this for the left part, you can see this its code is 46, and for the upper part, its code is 62, and for this one, it is 150. For different characters, you can find some component. For example, these are the 48 repeats. Okay, so but nobody used it before, even though the coding system exists. So our innovation is to integrate the coding system into an existing game. Okay, so the result is what? Without the coding system, you can see we highlight some region. The generated images are not so good as the one with the code system. Okay, so that's all. That's the how to train the neural network. There are some existing methods to do it, but with the new information source, we generate better results. So we published the paper in CPRW. W means workshop. It's not the main conference, but there are some workshops associated with the conference. Okay. Why we didn't submit to CPR? Because I think there are I think the audience of this topic is relatively limited. If they are interested in, they need to understand Chinese characters, and they also need to, I should say, this is a game based. So we submitted it to a generative workshop. The workshop focused on generative images. And then 2 years later, I helped another student publish the paper to Triple AI. So Triple AI is the top conference for artificial intelligence. Okay, the Triple is American Association for Artificial Intelligence. Okay, so in this paper, what we want to do is, given an image, we will generate a few sentences to describe the image. The input is image. The output is text, and there are different format of the output. It might be a single sentence, okay. It might be a paragraph consisting of several sentences, and for this paper, it is the latter one. We will generate not only one single sentence. Okay, so his idea is, given an image, we can use some object detection algorithm to know, okay, there is a bed, and there is a shelf, and there are some pillow. Within the pillow, there are something here. Okay, then, and since we know their relationship in terms of location, we can describe those information in the generative sentence. That's all. The idea is very straightforward and simple, and then we implemented it. And so this is our result. We generate so the CM B1, B2, B3, B2, B3, B4 are different metric, and we generate a state-of-the-art result, except for the matter metric. Okay. So, however, it is an improvement over existing methods. So the paper got in the Triple AI conference. Alright, and this is the paper we will publish it in ECCV this year. Okay, again, I help a student to publish, master student to this is his master thesis, and we try to revise it to good enough to be accepted in the tougher conferences. So the idea is, given some, okay, again, okay, let's go back to this slide. Here, this is the, I mentioned the NTU RGB plus dataset, right? And in this paper, okay, let's show, go to here, yeah. In this paper, we use the NTU RGB plus D dataset as our training and test set. So, as I mentioned, it is an action recognition dataset. So, it means given some actions, okay, we should say we split the training set into two different subsets, and in the test set, our algorithm never seen those actions, their classes in the training set. We only know their task description, and the task is according to those text description. We need to predict what the action is. So that is why it's called zero shot. And the skeleton based means the original format of the data source is video, and but all of them, what we care about is the human action. So we use some existing method to extract the skeleton of the humans from those videos already. So we didn't deal with the raw videos. What we deal with is the human skeleton sequences. Okay. So given the human skeleton sequence and some text label, we need to predict the classes from a test set, and we never saw the test set in our training set. So this is zero shot. Because I will go to ECCV in the early of October, so one of our course in October 1st, okay, I will ask another professor, Albert Marr, to substitute me for that day. Okay. And I will prepare my slide for him. He is also a professor working on computer vision, but his field is focused on medical images. Okay. So, but I believe he can teach you something. Okay. All right. So this is H5 index. So see this column. This table shows the important conferences around the world on computer vision. So this is the deadline, and this is the conference month. I sort those conferences by H5 index. So the best one is CPR. You can see it's greater than 400. And then is NIPS or new IPS. Okay, and ICLI and ICL. Okay. International conference on machine learning, for example, this one, there are a lot of papers. They are related to computer vision, but not totally the same. So I will say for computer vision, it will be CPR, ECCV, ICCV, and WACV. This is a winter application conferences on computer vision, British machine and vision conferences, and ICIP, ACCV, and future FG. So I rank their H5 index here. And for ICCV and ECCV, they are biannual conferences. Every 2 years, there's a conferences. ACCV is the same, all right? So what I want to mention is because the author of this paper, now he is working at Google, and the salary is very high, $3 million per year. Okay, and this girl, she is working at NVIDIA now. NVIDIA Do you know? Oh, sorry, not MediaTek, not NVIDIA. MediaTek. MediaTek is the biggest IC design house at Taiwan, and the salary is very very high too. And this one, the master of this paper, currently he is an intern at Google. I don't know whether he will become a full-time employee, etc. But however, what I want to send you a message is, if you can publish the paper at the TUF conference during your master program, you got the chance to get in very very good company and earn very very high salary. Okay. All right. Okay. So this is the history of computer CPR, the leading computer conference. So this is the attendance. You can see it is growing up and up, up. And this is accepted papers. Year by year, this is a trend. There are a lot of paper, and it is keep growing up. Okay. And this is submitted number, and this accepted number. This year, 2,700 papers were accepted. Okay, so you can so what does this mean? Computer vision, the research field, it is growing up. A lot of companies and a lot of people are doing it, and they are sponsors for CPR 24 this year. So you can see many famous brands and big companies there. Okay. So what is the difference for platinum, gold, and silver? It means how much money they donate, the different labels. Okay. All right, and these are the categories of the CPR 2024. So from here, you can see the most active research topic is image and video synthesis and generation. Okay. The same. Last year, 2023, it is still the most active research topic. Oh, right. Oh, here, the same. In this category, there were 329 papers accepted, and only 12 papers was the oral paper. So here you can see, even a paper getting a conference, there are two different levels. The best ones will be selected as the oral presentation. The first author will go to a stadium and present his paper to how many attendants? More than 10,000 audience. Okay. And how many percentage will be selected as the oral paper? Only 5. So you can see that 5% papers will be selected as the oral paper, and then the remaining, and then the remaining one, 10% of the remaining one will be the highlight. Highlight means you need to submit the highlight, the video, so that a lot of people, even you don't have time to present, even you cannot present your result online. There are some screens they will go play your pre-recorded videos in the conference, and then the remaining 85% will be the poster papers. It means they are not so significant, but you still have the chance to present your work in front of the poster to some interesting audience. Okay, so since there are so many papers, how to get them? So I recommend you to check this website, Computer Vision Foundation Open Access. Okay, from here you can see. What is the Computer Vision Foundation? Let me explain it. Before Computer Vision Foundation, if you want to access the paper, most of you will go to the IEEE Explorer. But in fact, IEEE Explorer is a very expensive website. The conferences, CPR, ICCV, WCV, they need to pay a lot of money so that their papers will be uploaded to IEEE Explorer. So they were unhappy. So they don't want to pay so much money to the IEEE Explorer. So they created a foundation to do it. Okay. So they created a foundation and uploaded their papers there. Everybody can download, read those papers for free. And currently, the Computer Vision Foundation supports 3 conferences: CPR, WCV, and ICCV. Okay, so if you want to read ECCV and ACCV paper, you need to go somewhere. But if you want to read the 3 papers of the 3 conferences, very easy. Just go here, and they are main conference paper and workshop papers. All of them are there. And once you click it and search, and you can see a lot of papers there and read them. You will gather the latest information. Very useful. Okay, let's talk about the textbook. This is our textbook. It is written by Richard Selesky. Okay, you'll find it. And he is a professor at Washington University, expert in computer vision. This book, he very generously releases it online for free. Everybody can download it. Okay. And this is the link of this book. Okay, there are 2 reference books. This is the Deep Learning, and it was written by Goodfellow and his co-workers. And this is the Simon Prince's computer vision. Okay, so pay attention here. This book was written in 2012. Okay, 2012 is a very interesting year. In this year, a very famous algorithm was published. It's called AlexNet. Okay. AlexNet is the I should say AlexNet let a lot of people know how powerful neural networks could be. The revolution of computer vision started from this AlexNet. Okay, so because this book was published in 2012, it means this is the conventional, traditional, or very old computer vision textbook. Okay. And deep learning, what it is published in 2016. Why? Because a lot of people start to understand if you want to develop a very effective function or effective tool for computer vision, deep learning is a required path. You cannot skip it. So Goodfellow, he is an expert in deep learning, so he reads the paper here. And let's see our textbook. It was written 2 years ago, very new. Okay, so it includes many new, I should say, state-of-the-art algorithm and ideas in the text in this book. Okay. All right. So and because you can see there are so many people in the world studying for computer vision. So there are many universities provide the full-length courses. You can get them online for free. So not only mine. If you are interested in I should say, some of you may not use computer vision for your job or your research topic. This is a required course, and you need to take it. But you may not use it in the future. For example, there was a master student last year, and she worked for AIoT. AI, Internet of Things, for okay. So computer vision for her is not very useful. But however, never mind. If you are interested in computer vision, there are some online resources which can help you. If you are not, then that's fine. Okay, you can get some experience here. Oh, so this is they provide not only videos but also slides. There are a lot of ways to Google it and find useful information here. Okay, so let's talk about the grading of this course. I will. There will be 4 pieces of homework. Not it will not very difficult because some of you, I say, will not use computer vision in the future, but it will be useful for you to get some experience. Okay. And so the 4 pieces of homework, you will see then later. For student who think he or she will not use computer vision in the future, you can try some tools for computer vision. For example, OpenCV. Just get an experience what it is and what it can do. If it can help you find. And for students who think computer vision will be very useful or important for your future, then there's another approach. Or you have rich experience of computer vision already. You do not need to do the easy job. You can take the challenging one. Okay, so there are 2 different options, and there's no midterm. Okay, I think you are graduate student already, and you have very diverse interest. Midterm is unnecessary for you, but you need. I think term project is good for you because you need to do some. I should say, Marcus, do you think a term project is useful for you? Oh, okay. Means your term project last year was very good. How do you think about it? $50-page paper? Whoa, great. Okay. So that's what I want. You spend the time and the money here. If possible, learn something useful for yourself. Okay. And let's go back here. If you are interested in the projects last year, you can go to here, Computer Vision 2023. Okay. And this is the slide last year and the video recording last year. I'm not satisfied with the slide. I think the quality is not good enough. Okay, I will try to revise them this year. But the important is the term project last year. There are 5 groups of students, and you can see their slides and the report. Okay, so this is Marcus' term project last year. Okay. So this is for your reference. Try, because your time and energy limited, so try to do as good as possible. Okay. Try your best, right? Okay, so what I want to say. All right. Okay. Yeah. So 60% of your grade will come from your term project, and there are several different stages, including your proposal, pitch, midterm report, and the final presentation, and the final project report. There is no TA for this course, so I will read everything by myself. Okay. And however, I want to warn you. The Office of Academic Affairs suggests all professors at in the university to set the average of the grading as 80%. So it means I would try to set the average of your score to the average or mean around 80%. Okay. So will it affect your scholarship or something else? Well, okay. So this is a warming. Okay, okay, right. So, okay. So let's talk about the homework one. So there are two options. The first, for the easier one, you can learn OpenCV because OpenCV is the most very useful and fundamental libraries for computer vision. If you have no idea what it is, use this opportunity to learn it. Okay, but if you have rich experience about computer vision, don't choose this option. Choose the challenge one to read papers, and read the paper. I should ask a question before. How many of you read the computer vision papers before? Okay, 1, 2, 3, 4, 5. Good, good. All right. So, how many of you use computer OpenCV already? 1, 2, 3, 4, 5, 6. Good, 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 good. So for you, I suggest, this is only suggestion, don't choose this one. It's meaningless for you. You have the experience already. Choose this one. Try to read some paper interesting you, and report it to your classmates. Help them to get the sense what the problem you are going to solve, and how the state-of-the-art method solve the problem, etc. Okay. And homework 2, okay, the easy one is to deal with some video data. Okay, you can use any type of library, try to solve any kind of problem as you like, but I hope that it is related to video, because in your homework 1 you use the computer vision, and the image is easy to actually if you have the experience of image, and try to solve some video related problem. Okay, and again, for those experienced students, I hope you can read some paper and validate the paper. This is very interesting. It means, okay, the result reported in the paper is so good, but are they true? Are they valid if I use another set of training and test set? Okay, because I'm also author of many papers. we sometimes show the best side of our results. Okay, so it is an interesting task if you want to validate. If you have some interesting topic, okay. Let me show you an example. Marcus' project last year, his teams validated 4 state-of-the-art deep-face papers, and because the 4 different papers use 4 different data sets, so when you close validating them, you will find many limitations. Yes. So this is my suggestion for the homework 2. For homework 3, again, I want to let you get the experience of neural network. Because in your homework 1 and homework 2, when you use OpenCV or any libraries, it may not use neural network, because OpenCV, some methods in the OpenCV library are very old. Okay, but the neural network currently it is almost the required tool. You need to be familiar with it if you want to develop some state-of-the-art method or algorithms. Without a neural network, the powerful tool, you may find what I can do. It's a big problem. So for homework 3, for the easy option 2, you can apply. You don't need to develop something. You just use some neural network tools to solve any kind of problem or tasks. But however, for advanced student, or I should say, for experienced student, if you want to challenge yourself, read some neural networks papers. And I think the ratio of papers using neural network currently is very high. I think it's greater than 90%. So if you are reading a state-of-the-art paper, more than 90%, you need to understand its neural network. And the homework 4 is we will try to let you get the experience to generate images from text or some stroke or something, etc. So this is a image generation task, and I have signed up for the our AI centers GPUs. For you who have no GPUs on your own, we can use their GPUs to do it. Okay, and again, for students who want to challenge yourself, try to read, report some image generation papers. There are so many papers to get it. So why? Let me show. Image and video generation is the most active research topic this year and last year. So there are a lot of papers you can read from. See how many 329 papers in this category. You just need to pick one of them. Not too difficult, right? And okay, but there are so many unsolved problems remaining. Find the one you are interested in. Okay, there's a time schedule for our term projects. Okay. Okay, so now let's go back to this I try to use as many as possible for images from our textbook, so that you can easily follow our progress, right? So this is okay. Let me in the beginning. Let me ask a question. What is computer vision? So for us, this is a flower. Very straightforward, right? And if I say the flower is foreground, and there are some background. For you, it's very easy. You can tell which is the foreground and which is the background, right? And what's computer vision? Computer vision is you want to find a method that machine can understand which pixel belongs to the foreground and which pixel belongs to the background. So computer vision is let machine or let computer can do what we can do in terms of vision problems. I think okay. Alright, so there are, in addition to the task, there are so many tasks. For example, for the first image, there are many faces in the image. If we want to locate where those faces are, so this is also a computer vision task and a problem. And if we want to detect where their clothing is, this is also a computer vision problem. Okay, given an image, you can see there are 5 servers, and there are 5 serving boats. And where are they? How do you segment them? And for different serving boats, you need to tell this. You assume they are different, so it means instant segmentation. If you treat them as same, then that means object segmentation. For the class of serving boats, okay, they are all the same. But for instance means they are different. Each serving boat, so you see here, for each serving boat, it uses different colors to label those pixels. And this is a 3D construction. It means if you have a camera and you use the camera to take a video, and when you go around, then can you reconstruct the building or architectures from your video? So this is also this is the 3D model construction problem. Okay, and this means if you have a stereo camera, or if you have a multiple camera, they are at different locations, and you reconstruct the 3D structures from the pair of cameras. So this is a stereo matching. Okay. All right. So the questions. How? So you see, if we try to let the computer know how to solve some vision tasks, the fundamental question is how do our brains work for those vision tasks? So there are some interesting questions. So it's called illusion. For this figure A, for the two lines, this one and this one, are they in the same size, length, or are they different? Of course, the answer is the same, right? But do you feel they are the same long? No, right? So this is the problem. How do our brains deal with those images or those visual inputs? Oh, okay, the second one, there are two region A and B, which is brighter. No, they are the same. They are the same. It's true, but but our vision system tell me B is brighter. Why? Because there are other clues. Because you see, there is something and created a shadow here, right? If in the shadow it is this so bright, then without the shadow, okay, it should be darker. So again, here again, when you see this figure, do you see there are some gray spots on those intersections? Yes, you do. But in fact, you can check. There is no gray spot. This is the result of our visual system. Okay, and here again, how many red cross at the left hand side? 4. Very easy, right? How many in the right hand side? 1, 2. Good, very good. Okay. But how is it? How do you know these two? Orion? Oh, okay, good. Okay, fine. But however, for most people in the first class, at the first class, it's difficult. So the same. Our visual system, there are some. Our visual, it's easy for our visual to detect the irregular or unusual patterns. So there are many applications for computer vision. So this is the reason you see there's a lot of companies they want to invest in computer vision because applications can help them make money, just like the companies I stated before. Okay, OCR and do you mean OCR is recognize characters from images. OCR, optical character recognition. And you can use the robots, and it can be applied on cars. Of course, there are many self-driving cars available right now, right? And medical image, of course. Some of you are working in the healthcare industry and should be familiar with this category. And mechanical inspection, this is very popular. Almost everything you buy from somewhere, okay, and the factories or manufacturers, they have certain medical inspection to check the quality of the product you buy. And drone, there are drone-based applications. All right, so this is a consumer levels of consumer applications of computer vision. The first is the image stitching. Do you know image stitching? It means if you have a camera and you take several images, then you can combine, okay, then into a single high-resolution image. This is called image stitching. And exposure breaking is when you press the shift button, then it will take several images, and the algorithm will automatically pick the one with the best exposure. Okay. And morphing is, I usually see the morphing in on TV commercials. Okay, it's very useful. It's for example this a lady and this animal, and then okay, it is gradually changed from one image to another images. And the smartphone augmented reality, I believe everyone has the smartphone, and either it is Android or iOS. Okay, there, if you use the map app, then for example, I use the Android smartphone, and then I use Google Map, and I turn on and I can see this one. Do you have the experience? There are some arrows telling me if I want to go to somewhere, which path I should go. Yeah. Do you have the experience? No, you never have the experience. Fine. Okay, try to figure it by yourself. Okay. Just set a destination and use then turn on the street view option. You can find it. Okay, so do you mean what is augmented reality? You know more. Okay, it means part of the image is the real world image, but part of it is not. So for example, this giraffe. Okay, it's impossible. I should say, the giraffe is generated, but the background is the real world street view. They combine together, and you looks like real. Alright, okay, so this is the history of computer vision. For different years, there are different research topics. Why? Because when a problem is solved, researchers they will use those findings to do next question or to try next problem. So year by year, there are a lot of questions to be solved, and around around this machine learning, it's what that the year AlexNet was published, and suddenly a lot of researchers in the world found that machine learning is so useful for computer vision. So a lot of people try to learn it, and there's also deep learning. Okay, and the vision and the language is just like this one. This is the example of vision and computation. They combine it together. We are going to solve the computer vision problem, but we use language because we use text to describe the video. Okay. So let's. This is a very old computer vision problems. Okay, so for this one, line labeling. Given an image, there are several lines here. How can we tell it which is which? Okay. For example, the intrinsic image, this one, it means given image, there are some shadows. Okay. What is the object in the image without the shadow? How do you remove those shadows? Okay, this is called intrinsic. And the pictorial structure. From this image, what do you think? It's a human faces. Because it looks like a human faces. There are eyes, nose, and edge, and the mouth. Okay. Where should be their location? Okay, so in the 1970s, this is I should say, due to the limited computational resource and data set, they try to address the very fundamental tasks. And go to the 1980s, there are a lot of new private and text software. For example, image the pyramid blending. So, what is mean? On the left left part, it is an apple, but on the right hand side, it is the orange. How do you blind an image of apple and an image of orange together without any artifacts? It looks like a very to say natural. Okay, it's not just a single combine. So how to do it? Use a pyramid structure. It means given an image, it shrink down to a low resolution one, and also and merge then layer by layer, and finally generate this output image. So you won't see many obvious artifacts on it. Okay. And okay, 90s there are some. For example, this one. It is this is given a pair of images. How do you estimate the depth of those objects in the two images? So this is the stereometry problem. And also like this one, this is a segmentation problem. It means this is the input image. It's a tiger, right? And there are some grass, and in the background there is a river. And there is a shadow here. How do we label every pixel of the image? So this is the segmentation problem. Okay. And this is also face tracking. Given a face or a video of faces, how do we localize the landmark points of the faces during the video? Okay. Those questions were addressed in 1970 and 1920. So this is image-based rendering. Is what? It's just the alpha mapping problem. Okay, let's show this one. Okay, this is the problem. If you can find the alpha map, then you can change the background. So yeah, okay, here this is one. So when I was at Sinica, it is around 2006. Okay, so this is the 2020 research topic. And for this one, this is the texture synthesis. This is a very famous MIT professor. He used his own face. Okay, and okay, in the upper part, there are a lot of cotton, but in the bottom part, it is still his face. So how to do it? How to synthesize textures based from a given image? So that is the research topic around 2020 to 2010. And okay, this is the feature-based recognition. So you see there are some motorcycles here. So because every motorcycle has a pair of wheels. Okay, so feature-based recognition means given the image, how do you know it is a motorcycle? Okay, the idea around those years is let's find whether there are two circles. If there are two circles, it is possible it is a bicycle or motorcycle. And so it means it try to find some features from an image and then compare those features to recognize whether the image belongs to the category of a motorcycle or bicycle. The research approach was developed until as I mentioned, in 2012, AlexNet was published. Okay. And before 2012 is 2011. The state-of-the-art recognition algorithm is the feature-based recognition. It was developed in the 2000 around, and go to the peak around 2011 and stop here because AlexNet showed a significant improvement for the recognition problem. Okay, let's take a break for 10 minutes. One of your classmates asked an important question that I forgot to mention in our slide. When will be the due of those homeworks? So this is, please go to our, I should say, if you go to our course website, you can see the homework 1 will due in 3 weeks. And then another homework, and another homework, and another homework. Okay, so 3 weeks later, there will be homework due. So I don't know whether I can go through those slides there. So let's go to our homework 1, and then let's try to explain how to do it right now. Okay, so this is the, I briefly introduce the computer vision library. Okay, it is a free open source library, and it was first released in year 2000 by Intel. Intel support these projects, and it was implemented. Okay, actually it supports many major programming languages: C, C++, Python, Java, MATLAB, and major platforms: Android, Windows, iOS, Mac, Linux, and there are a lot of free online available tutorial for this library. So for you, get the experience to use the library might be very helpful. Okay, you may not know how to develop the state-of-the-art computer vision algorithms, but use the ones developed by other people. This is it may help you solve some your problems. Okay, and the latest one is version 4.0, released a few months later. So there are a lot of things you can do, but let me show. Okay, there are a lot of books in our library or in the bookstores. You can go download it online for free. It's fine. And in our library, there are many computer vision OpenCV books. There are e-books. So you can just download it. A lot of, I think there's more than 200 books. So the resources for learning this library is abundant. And this online book, so free. This is free. Okay, for pay attention, free. Sorry. Okay, here. Okay, and some of them are not totally free, but you can get it for free. For example, this one, and the author release its code. So if you want, if you don't want to, oh, by the way, there's another approach. You can use Gemini or ChatGPT. Ask them, give me a piece of code using computer OpenCV to achieve certain results. Useful. I tried it. Very, very useful. Okay. Now you are in the year of 2024. Don't forget the tool. It's very useful for you. Okay. Oh, if you want to code here, the author releases its code, the whole copy of its code. So you can get the copy, or you can just Google. Maybe someone else share the book online. We don't. So you need to, according to the rule of our regulation of our university, you need to pay attention to the copyright. Okay, copyright important. Don't violate the copyright. Okay, even if you can find some copies from Google. Okay, right. So here, this is. So if you watch YouTube video, there is no copyright problem. So there are a lot of YouTube videos or any kind of video teaching you how to use OpenCV. So this one 9.5 hours, very new, 2 years, last year. Okay, but it has no code. You need to, if you want to use their code, you need to key in by yourself. And this one 3.7 hours, 4 years ago, and the code is available at GitHub. So there are so many. Okay, let me show you. Let me give you a sense what OpenCV can do. Given an image, if you want to remove this background people, what do we do? Okay, and there are some online tutorial. This this one. The task has a name, impending. Okay, it means you can remove part of your image, fill it with the content you want. So if you click this link, you can watch the video and learn how to use OpenCV to do the impending task. Okay, there is once you know the keyword impending, then you can easily find online courses or online tutorial to learn how to. So keyword, I should say, knowledge. Once you have the basic knowledge, will be helpful for you to find the resources to do it. Okay, so this is another one. Using impending using OpenCV with Python, because OpenCV supports different languages, so you can try to use the language you are familiar with. Okay. And okay, let me introduce it. Okay. So impending means, given the image, you create a mask first. You want to use algorithm to fill in the mask. So, for example, this one, I use GIMP. It's a free. It's like Photoshop, but it's free. Okay. So I use GIMP to create an image mask for this part. Then, to do it, I only use nine lines of statements. Okay. So import CV2. It means use OpenCV library. So this is a Python language. Okay. So then OpenCV provide a function inRead. It means read image. In means image. Read what image? This image, and it become my variable. And then I read the mask. Okay, and I tell OpenCV the mask is a grayscale. Okay, then I have two variables or two images in my computer. Then I call OpenCV's impend function. So the first parameter is the source image, and the second parameter is the mask image. And then there is some options for the algorithm. So there are two algorithms provided by OpenCV. One is Telia, and another is okay. Here, another is NS. So if you want to the impending function in OpenCV, you only have two options, either NS or Telia. What is Telia? Telia is the author of this algorithm. It is created by Mr. This is Mr. or Mrs. Telia. Okay, so you can see 20 years ago, it is a state-defined algorithm, and somebody implemented it as a piece of code. Then OpenCV contain the code. You just call OpenCV to use the algorithm. Okay. All right. So if I use the Telia algorithm and I need to set a parameter for the Telia algorithm, it means the radius of each mask. Then the generated image will be the destination one. Okay. I used inWrite to generate an image from my memory. Okay, then I can find the file in my disk. Okay, let's see some result. If I set the radius as 3, this is the result. 8, 13, 18, 23. So you need to tune the parameter by yourself. Okay, And also, this is the result of NS algorithm and the result of Telia algorithm. It looks like Telia works better than NS. Okay, and so it looks like this. If I use Telia and I select the parameter of the radian as 28, this is the result. It's better than the original one, but the artifact is still I cannot skip the obvious. If you slightly pay attention here, you feel something wrong. Okay, and why it doesn't work well? Because the two algorithms, either of them, they assume the risk measure is striped, like this one. So this image is downloaded from OpenCV's tutorial online. Okay, for on the official website. If you are in mask region like this one, your results looks okay, but for us, our mask region is blocked, so it's too wide. Therefore, the two algorithms do not work well. Okay, is there any better algorithm? Okay, let's remember the two algorithms were released 20 years ago. Within the 20 years, is there any other algorithm? Yes. Yes. Okay, so this is also an impending algorithm published in NURBS, NUR IPS. Okay, in the beginning, the conference was called NIPS, but the NIPS also is the name of the your student. So it changes system to NUR IPS. Okay. Okay, this is impending algorithm. It is a learning-based algorithm, so it trains a neural network for it. Here is the example. If you given the image, if you crop those regions, and this is the generated image, it looks like very good. It's difficult to spot the reconstructed or rebuild region. Okay, given an image without the central face area, it can reconstruct the image. So it looks useful, but however, it is not included in OpenCV. Okay, but it is included in OpenVINO. OpenVINO is another library. It is a library also provided by Intel, free. You can support many platform and language. Okay, so if you check the places to dataset in OpenVINO, you can find this algorithm. Of course, you can try. Okay, this is the OpenVINO's tutorial page. Okay, so here is the. Okay, it's easy for you to Google it. Okay, and you can scroll it down, and there you can see this example. So what I want to say is, for your homework one, of course, if you have no experience and you can try OpenCV, but don't just restrict to yourself to OpenCV. You can also try OpenVINO if you like. Okay, my motivation is let you give yourself a chance to learn the public widely used library, because it is a tool. It can help you to solve the problems. Okay, so this is a result using OpenVINO's. So here, let's compare them. So this is input. This is the OpenVINO's result, and this is Telia's result. I think this is better. I hope you also maybe okay. I think most of you will agree with it. Okay, so this is for your homework one. If you have limited experience, and because I should say, we have two options, right? Let's go to the page. Yeah, it is good for you to read the papers, but it may be too difficult for you to read papers, because you need to have some fundamental knowledge so that you can fully understand the papers. Never mind, try option 2 for new learners, no problem. And okay, however, I want to say, so that's why I no. Okay, so I hope the introduction to OpenCV and OpenVINO can help you to do your homework one well. And some of them may generate a very interesting results or very good findings. Then I will pick some of them, the good of among you, and let you do oral presentation. Let you share your findings or results with your classmates to help them to understand understand computer vision. Okay, so of course for the experienced students, try to read some papers. It's good. Read the papers is useful for you if you want to publish the papers in the future. If you publish the papers in the top conferences, you got a chance to get into high salary pay jobs. Okay, and I remember one thing. If your paper got in CPR, then I remember our university will sponsor those students to CPR. Maybe I forgot the amount of money. I'm not sure how much it is. But however, let me explain it clearly. If you were master students and you publish a paper in CPR, you definitely will get the sponsorship from our university to the conference. But you are master students. I don't know whether you will get the sponsorship from you. I'm not sure. Okay, but maybe I need to ask somebody else who make the regulation. Right. So that's after talking our computer vision course. Okay, here we go. Yeah. Okay. We stopped here, and this is called region-based recognition. So from this, you can see what is he doing right now. Okay, after this image, what is this? What is he? Okay, I would say he just swinged his. He's a basketball player, and he just swinged his bat. Okay. So, however, what I want to say is, given the image, the region-based recognition want to recognize what the image is from regions. So what is different from the feature-based? Feature-based is it want to extract some features and use those features to recognize the image. And the region-based, first of all, we need to crop some regions, and from those regions, we try to recognize the image. So in around 10 years ago, the two approaches went together. And in the last decade, because of the redevelopment of neural networks, the two approach, feature-based recognition and region-based recognition, they almost vanished. Okay, because neural network is too powerful. It's very, very powerful to outperform those two approaches. Okay, so this is the segmentation problem. Neural networks also show it's very effective to solve the segmentation problem. And this is the given the image, we want to predict the key points. So this is scatter. So this is what I'm going to present in ECCV this year. Okay, I should say we use the skeleton structure to predict actions, and this is the skeleton structure. Okay, so there are several different representations. just key point, skeleton, or the structure. So this is, we are going to predict the depth. Also, this is augmentation, and this is a real-time 3D method. So, what is the image? There is a drone in the air, okay, and the drone will follow this runner behind him. So and there is a forest. The drone need to skip those trees, otherwise the drone will collapse. So it need to reconstruct a 3D map from the camera of the drone, and it has to be real time. Otherwise, you cannot. If there is a significant delay, then your drone will you will lose your drone. Okay, so in the past 4 decades, you see more and more computer vision problems are solved. Okay, why? The fundamental force is the improvement of semiconductor. Okay, so let's see the figure. This means let's just see the past 14 years. From 2010 to this year, okay, this is the price per US dollars. How many flaps you can you spend $1 US, how many flaps you can buy? So you can see this is a trend. Year by year, it becomes very cheaper and cheaper. So because you got so many computational resources, of course you can solve more problems. And the second force is data, because the innovation of image sensor, in particular CMOS image sensor, you can okay, I don't know whether you still have the experience. Before digital camera, if you want to get an image, there is a material called film. Do you have the experience? You use the film in your camera and take picture, and you go to the camera shop and they will print it out the phone. Okay, now everybody is using cell phone. Cell phone even replaced digital camera. Okay, so now it's free, abundant everywhere. So because of those available data, you can, I should say, develop many algorithms to address different problems. Okay, so let's see. Okay, computer. There are some related research topics around computer vision. Okay, and let's distinguish what is difference between computer vision and image processing. Okay, so if their purposes are different, for image processing, we want to beautify images, or we want to make the images useful for us. But for computer vision, we want to understand the images. And what is the output of computer image processing is also an image or images. But for computer visions, we will try to learn something from the image. So we may generate labels, text segmentation, or text structure, etc. So there are some examples. If you want to, okay, if you found that there are some noise in the image, and you want to remove those noise from your image, that's the computer vision. No, this is the image processing task. But if you want to recognize what object is in the image, it is a computer vision task. However, are they overlapped? Yes, they are overlapped. For example, this is the landscape mixture. It is a feature of Photoshop, and you can also find the feature even in your cell phone. So what does this mean? It means you take a picture here, but you want to change the content of the image. For example, this is the input image, and you want to get the scene of the same image but in winter. So you can see those pyramid was covered by snow. Okay, so how to do it? First of all, and this you want to change the image and make it look like in a desert. Okay, and this you want to change it like in the fall. Okay, how to do it? So first of all, you need to understand the image, then apply some image processing method to beautify the image. So this is the combination of image processing and computer vision. Let me show you another easy example. If you have I should say, there are some app in your cell phone. You can blur the background. Okay, so it makes your photo looks better. However, just like our first question, for our vision system, you can easily tell which is the foreground, which is the background. But for computer, you need to teach computer to understand how to tell the foreground and the background. Once it can understand the foreground and the background in the image, then it can blur the background only. Otherwise, it will blur the foreground. So, to understand which is foreground, background, this is the computer vision problem. And blur the background, it is image processing problem. You can just apply a Gaussian blur filter, then you can blur the background. Okay, so what's the difference between computer vision and the graphics? Okay, let me explain here. Computer vision means, given an image, we want to create a model. So this is just an example. Okay, and the graphics means, given a model, we want to render output images. So is there any combination of computer vision and graphics? Yes, deepfake. Deepfake means, given an image, you want to generate another image, but they looks like very similar, or in certain the same pose, the same facial expression, etc. So how to do it? First of all, you need to understand the image. Where is the localization of those facial components? What is its expression, and what is its pose? Then you use a graphic method to render new images based on the knowledge you learn. Okay, based on the structures of the data you learned from the input image. Okay, now computer vision is also related to cognitive science. Okay, first of all, see the image. So, do you see 4 separate scenes or just a single scene? Of course, you are very smart. You know, if I ask the question, the answer, of course, is a single scene. But at the first glance, do you think the 4? You may have the feel. Before I ask you the question, you should, what is the there are apparent 4 parts, right? Okay. So let's change another viewpoint. Okay, this is a single scene. Okay, yeah. And okay, Aurea, you come from France. You know this site, right? No, you don't. Okay. It looks like globe. So, in fact, okay, it's a Paris City Hall glass globe. Yeah. Okay. Fine. So, in fact, it is a landscape, but it looks like a globe. Okay. So, you see many rows here. It in fact is the white lines here. Okay. So it's a funny illusion. So of course, I believe some of you have the same experience. Someone draw the bigger a picture on the ground, and okay, it's look okay, and the left hand side part is funny. Okay, so of course it's a very famous landmark, right? The Pisa Tower. Okay. All right. So okay, quick question: what do you see from this image? Yes, a dog. some people can find this dog, and some people will find, okay, there is a people, there's a person who is walking into the forest. Okay, so but do you find? Is there anybody know what who didn't find a dog? Is there a dog? Where is the dog? Orion, please, could you help your classmate to know where the dog is? Alright, okay, in the middle of the picture. Okay, this is the dog's head, front leg, back leg, and this is the tail. Anybody doesn't catch it? There is a dog. The dog is running from the forest to the photographer. Okay, right? And oh, this is a very famous picture. Do you find something in the image? Okay, this is a clue. Dalmatian. Dalmatian is a breed of dog. Alright, okay, so in the beginning, okay, this is a photo. Here is a dog. This is a dog's head. This is a dog of front leg, second front leg, and this is a rear leg. Okay, so because the main, okay, here. Okay, so there is a paper published in 2000. Okay, it is so why I say this is computer vision is related to cognitive science, because they call a lot of human subjects and ask them, what do you see from this image? Some of them say, oh, I found a lion, a bear, a jaguar, an elephant. Okay, so this for different people, they got different feelings. So this is a cognitive science part. Okay, so this is interesting. And okay, there's another paper. It was so what they found is, so this is the original image, and if they change the orientation of those spots on the dog, like this one, so it is vertical, and here it's become this is vertical, and this is become horizontal. Here. Then they found the percentage of people they can spot an animal in the image will reduce from 75% to 45%. So that okay. What I mentioned, this is not a computer vision problem. This is a recognized task, the problem they are going to solve, but they are related. Okay. So there's another interesting paper. It was published 9 years ago. Okay, it means in addition to this image, can they generate other similar images rather than Dalmatian? Can they try other different animals? For example, the gorilla. Do you see a gorilla in this? This is called emerging image. Here is a gorilla. Alright. Okay, so fine. So this is I should say this is a computer vision problem. This is a cognitive science problem. Okay, so if you are interested, of course, I show the paper here, so you can read them. Okay, so and there are many interesting findings. So how do they do the experiments? First, so this is the initial, I should say, the motivation of the study. Their Dalmatian image is very famous, so they want to reproduce some similar images, so that they can test their human subjects. And in the beginning, they give the subject 4 different types of hints. The first of all is no hint. They just show a white spot. And the second type of given the sun shape, also the source model. And the third type of hint is given an image of gorilla, but they looks like a different. Okay. The fourth type of hint is given the text description. Okay. So they will use timer to record how many minutes do those human subjects need to find out the animals in the merging images. So, okay, so they can get some findings. So if they give the same shape of the random force, then it means their accuracy to recognize the animals in the merging images is the highest. Okay, and okay, so they also use the eye tracker. So this is the eye tracker to understand at the moment when their human subject recognize where the animal is, where do they watch at? Okay, so this is the at the first 500 milliseconds they are looking for where is the animal, and around 1 second they found at the moment of recognition. Okay, they know here is the answer. Okay. So again, I want to say in those slides you can see this is the recognition science task, but here is the connection between recognition science and computer vision. Okay, it means in computer vision there are some algorithms called saliency detection. It means given an image, they want to know where is the most important part of the image. It means the saliency. Okay, so they tried two different saliency algorithms. One is ET, another is GBVS, and they apply those computer vision algorithms on those emerging images. This one, and this generated result. Okay, the heat map. The red color means the algorithm predict this region is the most important, most informative regions, and also that's one. So what do they want to show? They want to show the state-of-the-art computer vision algorithms doesn't work for the emergent images. So this is the connection between recognition science and computer vision. Right? So okay, let's go back. How do we get images? So this is a real world. It is a 3D world. And what is image? Image is a 2D plan. It's a okay. So how do we generate it? In fact, it is a dimension reduction process from 3D world to get a 2D image. Okay. So okay, let's use some mathematical expressions. To describe a point on a 2D plane, we use x, y, the first axis and the second axis. And there is another term. It means a homogeneous coordinates. You will have a third dimension. But however, you can scale the homogeneous coordinate, but they present the same 2D coordinates. Okay. So this like one. This for this coordinates x tilde, y tilde, w tilde. If you move the x tilde out of the coordinate, it will be x, y, and 1. But the two expression, this one and this one, represent the same 2D dimension. Okay. Why do we need the homogeneous coordinate? We will see the later. Okay. And with the additional one, we call this augmented vector. Alright, okay. So we use another vector, say ABC. How do we describe a line in a 2D plane? Okay, it's very simple. You use augmented vector times the another vector ax plus by plus c equals 0. Then this is representation of a 2D of a line on a 2D plane. Okay, so there are some advantages of the homogeneous coordinate. Okay, Okay, I just show some hints here, and okay, I think this is slightly boring, so let's keep it here. If you want to know details, read your textbook, okay, because all of them are written in the textbook. Okay, so here, once we have the 2D lines here, there are some terms. First, the normalization. So normalization line equation, it will be like this. So the hat n x and hat n y is the normal vector. It means this one, coordinate perpendicular to the line, and it's normalized. That means the length of the vector is equal to 1. Because it is equal to 1, so it can be expressed as a combination of sine and cosine. And the theta here is from the x-axis to the normal vector, okay? And the d is the distance from the line to the origin. Okay. So I think most of you use these symbols in your high school or in your undergraduate courses. But however, you have different backgrounds, right? Some of you are expert in medical, and some of you are engineer or computer science. Okay, however, we try to use the same symbol I just follow the same symbol as our textbook, so that when you read the textbook, you will easy to follow it. Okay. How do we describe a 3D point, a 3D plane? The same. We just need an additional variable z. It means the third dimension. Okay, and again, there is a augmented vector for the 3D point. And how do we describe a 3D plane? It's very similar to the way we describe 2D lines. It means we use the homogeneous coordinates and times a vector. And with ax plus by plus cz plus d equals to 0, then we can describe a plane in 3D. Okay, but however, if we want to describe a line in 3D, the expression is not so elegant. Okay, there is no homogeneous coordinate useful for it. To describe a line in 3D, the most popular, actually widely used method is given a pair of points P and Q, then we use another parameter lambda. Okay, the different lambda means the different positions on the line. Okay, so if lambda equals to 1, it means it is the point of Q. If lambda equals to 0, it means the point of P. Okay, then this is the 2D translation. Okay, there are different terms. You keep it just keep it in mind, and if you read some papers and they use the same terms, you can know what it means. So translation means just move from one place to another place, and Euclidean means you not only move them but also rotate the square. So this is square, and but this Euclidean, it is rotate. Why it is called Euclidean? Because under this translation, the Euclidean distance or the length keeps the same, not changed. And there's a similarity translation. It means not only move and not only rotation, but also scaling. So you can see that in a similarity translation, the new square becomes slightly less. Okay, and there is a affine translation. Affine translation means that a pair of parallel lines in the original shape will keep the same. It is still parallel. Okay, and for projection, it is the only property you can reserve is it is still a line, but it can be any kind of shape. Alright, so this is so how do we wrote it? Okay, for Okay, for translation, it looks like this. X prime, the new location, would be the original location times identical matrix, and t. T means the shift or movement for x and the y-axis, right? And for Euclidean distance, the equation becomes this. We have rotation parameter, the theta. Okay? And for similarity, we have a new factor called scaling factor. Okay. And for affine transform, okay, there will be more parameters. Okay, there's no, and it should say those parameters can be any values. Okay, but however, this is still a linear transform. So the line in the input shape, input shape will keep unchanged. It will still be a line in the output shape. Okay, because this is a linear transform. And for projected transform, okay, this is why we need the homogeneous coordinate, because projected transform can only be expressed in homogeneous coordinates. We cannot use the naive coordinates x, y to describe the projective translation. Okay, so this is a homogeneous coordinate, and there are 9 parameters. But however, it is because it's a homogeneous coordinate. What does it mean? The scaling of those 9 parameters doesn't matter. Okay, so in fact there are only 8 degrees of freedoms for. Okay, so if we, okay, you can find the table in the textbook at the same. Okay, what I want to show is, so this you can see this hierarchical or family of 2D transformation. So with higher degree of freedom, you can change the shape of the input structures to different types. The set, there is a 3D transform hierarchy. Okay, well, there are more degree of freedom because it is in a 3D space. Okay, so why do we? So that's the reason. As we mentioned, how do we get an image? It is a dimension reduction process, right? Okay, from 3D to 2D. So it is a process of projection. Okay, given a point in the 3D world, suppose its coordinate is x, y, z, then what will be its coordinate in a 2D plane? Also on a 2D plane. So there are several different types of projection, and the most widely used one is a perspective projection. For example, given this image, suppose there are 2 cubics, and in the 3D world, their images on the 2D planes will look like this. And how do they do? For those corner points, where will they be in the 2D plane? So the easiest way is just divide the x and the y coordinate by its z coordinates. Okay, so if we wrote it in the homogeneous coordinate, and it will look like this one. Okay. All right. So we go very quickly through those mathematical equations, and I know mathematical because it takes time to fully understand those equations. But however, all of them are in your textbook. I just want to go through it quickly and give you some impressions that if you want to figure out those details, read those textbook. Okay, then let's talk about the camera. Okay, we know 2D images is a projection of the 3D real world, but what is the device we use and how those devices work. Okay, so in the very beginning, this is a pinhole camera. This is very fundamental. So how old it is? Okay, you can from this figure you can see maybe 2,000 years ago. Yeah, people knows the pinhole camera can generate images. All right. Okay, we use all of time today. And do you have any question? Okay. If no, then fine. Okay, this is the end of our class. I'll see you next week.